Hello again, this is the course of data structure and algorithms, and today we are going to discuss about the analysis of algorithms. Before this course, you already learned about the Python and how to deal with the object-oriented programming, and now we are going to learn more about the analysis of algorithms, and most of the contents of this PPT, I used the slide from the course the book Data Structures and Algorithms in Python, written by Goodrich, Tamasya, and Kulverser. So the discussion of this PPT will be about the pseudocode, some important functions, the 7 basic functions, and the big O notation and the variance, the complexity analysis. First, we are going to discuss about pseudocode. Why do we need to discuss about the analysis of the algorithms? Because the algorithms will transform input object into output objects. And when you transform the input object to the output objects, there will be a process in between. Okay? The process in between of the input and output, it will be very depending on the process, and it also depend on the input. Okay, so the running time of an algorithm typically grows with the input size. When the input grows, then yeah, you need to know the uh, computation time. And yeah, usually we use the average case time, but it is difficult to determine because the average case time is the time that you need to get when you implement the algorithms. And average is very difficult also if you need to run many experiments. So we can focus on the worst case running time. Why? Because it is easier to analyze. So once you know the worst case, it means it will be the representative time for your algorithm. And the worst case is also crucial to applications such as game, finance, and robotics. For example, if you play games, do you want to play games with a very long algorithms? Okay, you don't know. Okay, maybe if you uh, run, if you play with Mobile Legends. Okay, so you want to play the games with very smooth ways. Okay, so the time computation for a particular process is very important. Finance, you need to get the information in real time. Then it's also important to know about the good algorithms. And robotics, once the robot move, then you want to know that the robot moves in exact position and with the correct process. And those things, those algorithms need to be executed in a particular time. So the time is very important, and if we want to run the algorithms properly, then it needs many experiments and it requires a lot of time. So the worst case will be the best way to know the algorithm complexity. If you can plot this one, okay, if the input size it says like 1,000, 2,000, 3,000, 4,000, and let's say the pink color is the best case, the worst case is the average case is the blue one, and the red one is the worst case. Then you can see, if I know the worst case, it means it will represent the best case and the average case. So I know that it is in 10 minutes, the average is 8 minutes, and the best case is 5 minutes. Then I can say, okay, let me give you 10 minutes for this algorithm. Okay, so that's the worst case, and of course, it is very important to know about the concept of the worst case. And the experimental studies, you need to implement the algorithm, and also you need to get the time. Run the programs with various size and composition, noting the time needed. And you need to run this algorithm, like say, if the size is 10, how many times do you need? If the time is if the input is 20, how many times do you need? If the time is 30, how many times do you need? If the time is 40, how many times do you need? Then you need to replicate this one until you get the result of the, for example, 90 or 100. Once you plot all those numbers, then you can see, okay, when the input size increase, the time is increasing with this function. Yeah. So the plotting you can get the plotting by giving this code, okay, from time, import time, and so on. So let's see. I'm going to the Jupyter notebook. So let's say I have one function, okay, and this function have one argument, and the first variable is tot, T-O-T. I guess it is a total, and the number, the initial value is 1, and I want to loop. Okay, I want to loop from I. The I is a range from 1 until n, and let's make the total equals to the total plus I, and I want to return the value. This is TOT. Okay, so I will run this, and let's see if I have factor 10. So n is 10. Yeah, then I will loop 1 until 10. So this number will be added. So 1 plus 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 and so on until 10. Then the result is 45. Okay. Yeah, I don't care with the initial value. But now let's see. I want to know if the time, okay, the starting time, this is the time that you want to get. It is from the library time, and then you will get the end time, and the elapsed time or the execution time will be the end time minus the start time. So you will get the elapsed time, for example, 0. Why? Yeah, it's very short. If your number is 10, it's very short. What about if I increase the number 100? Okay, it's still short. How about if I increase to 1000? It's very short, 0. So it doesn't care about the time. Okay. Okay. Now it is increasing. Okay, 0.029. If I increase again, this is increasing, right? 0.018. So what about if I increase one more? Wow, it becomes 0.1 second. How if I add one more? Oh, now it takes 1 second. Okay, so by this kind of experiment, you can see the numbers, and then after you do something, you can plot those. Okay, and once you plot the numbers, the numbers will be something like this one, maybe. Okay. Yeah, this is one way to analyze your program, but yeah, there are some limitations for this one. First, it's difficult. Okay, when you have your algorithms, usually you will design. Okay, once you design the algorithms, you need to implement the algorithms, and it takes time. So the time to implement it's difficult, and also to run the experiment is also difficult. And also there are some other factors with the external parameters. The results may not be indicative of the running time on other inputs not included in the experiment. So for example, if you have um, you want to calculate about some future values of particular monies, okay, so you know the good condition. Okay, you can say that, okay, I have interest of 10%, and now I have $1,000. So how much money that I can get in next 10 years. Yeah, it's easy if you have the calculation and you have the calculation of the future values. You can just input the interest, and then you can just input the present values, and you know the future values. But there will be another input that you will not consider. For example, like this kind of condition with the coronavirus, you may not know what is the parameter that will influence the future values. Okay, so it means the algorithm should be adjusted with some kind of situation and condition. So those kind of input will affect the experiment, and it will may give you more complexity. And the other thing is about the computer specification. You're doing your experiment with laptop, it will be different with the experiment in the desktop, because usually desktop will have more specification, will have a higher specification than the laptop. But yeah, it depends. Even though you have your own laptop, your laptop will be different with my laptop. So the computational time will be also different. So this kind of limitation will cause that the analysis will not be so accurate. So you cannot get the accurate analysis because of this limitation. That's why um, some people say that it is better to go with the theoretical analysis. So what is theoretical analysis? It is a high-level description versus implementation. So you want to describe the algorithm instead of implementation. You will not need implementation, but once you have the theoretical or you have the high-level description, it is enough to analyze it. The other thing is about the running time functions. You can characterize the running time as a function. Okay? So this function, it will be depending on the input size. And the input characteristics, you can just take into account all possible inputs, because for example, N1, N2, N3, N4, N5. So if there are many inputs, you don't need to worry about those many inputs, but you need to consider how many. Okay. And when you analyze that one, you will analyze the algorithm, not the software. Okay. It means you will allow to evaluate the speed of algorithm independent of the hardware and software. So you don't need to worry if I'm running this one in my laptop, if I'm running this one in the other laptop, if I'm running this one in the school's computer. So yeah, because it is about the theoretical analysis, it is about the algorithm analysis. So it is not depending on the computer. So that's why we call it as the theoretical analysis. And using the theoretical analysis, we need to know about the pseudocode. So what is pseudocode? It is a high-level description of an algorithm. It is more structured than English prose. So yeah, there's a structure for this pseudocode, less detailed than a program, preferred notation for describing algorithms, and hide program design issues. So I don't need to write something with Python like if, and then we have the condition, and then we have the colon. Okay, you don't need to follow that one, but you just express it. For example, you know the concept of control flow, if, then, and else. You know the while do, repeat until, for do. So uh, those control flows is the way to express it in only with very simple English. And maybe you can say that, okay, I need the indentation. Yeah, yes, true, but you don't need to consider that one because it is the theoretical analysis. The method declaration. So I need to declare the method, and then how many arguments do I have to put, and then what is the input and what is the output. Okay. And then when we call the method, yeah, of course, we want to call the method with the arguments, and then there are some written values, okay, and there are some expressions like assignment, equality testing, or the subscript and other mathematical formatting is also allowed. So the pseudocode is very flexible, and it depends on the, yeah, it depends on the authors actually. So you can define your own way to write the pseudocode. There is no such kind of standard, but usually people will know what is the good way to write the pseudocode. So before you know more about the pseudocode, so I would like to mention that the memory is important because when you're doing the experiment, you need to understand that your CPU or the central processing unit or the desktop or the laptop that you have, they have the memory cells, okay, and these memory cells can hold an arbitrary number or character. So those memory cells are numbered, and accessing any cell in the memory takes unit of time. Okay? So when I access this computer, there will be, if I access the number 0, if I access number 1, if I access number 2, there will be some time. Then, yeah, we want to understand how the time influence the processing algorithms. So some important function that you need to understand is yeah, there are 7 functions now. We will learn only the function like the constant, logarithmic or log n, linear n log n logarithmic n, quadratic, so it is n power of 2, cubic n power of 3, and exponential 2 power of n. Okay, so those functions are the 7 basic function in the analysis. And yeah, in the log chart, the slope of the line corresponds to growth rate. So the horizontal line, it represents the number of inputs. So n, when the n is getting higher, then the tn means the time is also getting higher. Okay, so yeah, this is the graph actually for the 7 function. If it is constant, then yeah, the is horizontal line, so it is the steady time. If you have the log n, then the graph something like this one. So it high in the first state, but it will be not steep in the next phase. If it is linear, then just have the line like this one, and n log n, yeah, we have a slightly growth or gradually growth in the latest part, but it's not that high. When you have the n power of 2 or n square, it is higher than n to n. What about n power of 3? N power of 3 is more steepest, so it's very fast growing. But the fastest one is 2 power of n, so it is the exponential growth. So now if you are following the news about COVID-19, so many people said that the growing of the coronavirus is the exponential. So it follows with this figure, okay? So how can you deal with the analysis, that one? Okay, before I go to the before I go to the operations, I would like to show you one slide. It is the slide from the book, okay? Yeah, I already show you this one. Now, yeah, if you are doing with some of the basic uh, some of the basic function like the logarithmic, linear, log linear, quadratic, cubic, and exponential, then you can see which one is the best one. Yeah, of course you want to know the constant. The constant is that's the very low one, and there's the people who are interesting for making the algorithm. So if the time is constant, of course it's very useful for any operations, but it's very difficult to get the constant. At least you can get the logarithmic or linear, okay? But if you can get the logarithmic, it means the process is very small, okay? The process is, is very fast, so you can apply in many other domains. But if your process is exponential, it's very slow. You have we will have a lot of difficulties to implement it. Yeah, in previous days, anacondas is also a powerful tools to analyze this one. So there's a link. If you want to get this link, okay, I will share it to you. Actually, I put this one into the Jupyter notebook. Okay, if you click on this side, there will be a code. We call it the algorithm analysis.py. It has been developed by this person, and someone already modified it in order to get to know what is um, the analysis when we make some random function or random values. Okay, so there are some functions like constant, logarithmic, linear, n log n, quadratic, cubic, exponential. Okay, and yeah, we are doing with those stuff. Let's say I have the shuffle. So shuffle means I want to shuffle the numbers. After I shuffle the numbers, I do the sorting. So sorting algorithm after we do the shuffle, and then just plotting. Okay, so the plotting means I want to plot into one graph, so you can see whether the logarithmic function is better than exponential. Now, at the last part, we have the main function. So the main function is to analyze the algorithm based on the plot. Okay, so we're going to plot the TC constant. We want to plot the logarithmic, linear, and log n quadratic cubic exponential. Yeah, if you want to deal with the shuffle and sort, yeah, you can check this one. But let's focus on the 7 algorithms. Okay, so you can use this one, and I will run. Yeah, it takes some time. Okay, so it shows the constant 10 upon step 10. What does it mean? So here, if you're going to constant, we have the n. Okay, oh, it seems interesting, right? There are many parameters, but you have only one. So the n, it represents the oh, sorry, this is the plot TC. Okay, that the plot TC here, we want to get the function. What is the function? So the function is constant, and then the minimum is 10, and the up bound, okay, the up bound is 24, and step is 1, so it will be added by 1. And then last, you want to test it with the 10 number, and this is the loop. The loop is from I to the range, which is from the minimum until the maximum and the increment. And then let's make the n equals to I. So I will make the timer. So every time it calculates, so it will save the numbers into the timer. And after we have the number, then we put it into the variable x and y, and we will plot this one later with this plot. Okay, so the plot will be in the PLT, and yeah, after that we will give the legend pass. So based on the functions like constant, logarithmic, linear, and so on, so we make the legend here, the constant, logarithmic, linear, and log n, quadratic, cubic, and exponential. So which one is the best? Yeah, even though it's constant, okay, you can see, right? So the theoretical analysis shows that the constant is just a horizontal line, but in fact the constant function is not only horizontal. It's there is a kind of fluctuation when you implement it in the computer. The logarithmic function, yeah, there's also another fluctuation, but it is higher than the constant, the normal constant. The linear, yeah, oh, it seems not linear, okay. But yeah, this also another things. The linear is somehow mixed with the logarithmic function. So sometimes logarithmic is better, and sometimes linear is better. That's possible. Okay. And like n log n is the red one. Of course, it is higher, and the quadratic is also higher than the others. The brown color is cubic, and the last one, which is the highest or the worst, is the exponential. Okay. So by using this function, we know that, yeah, try to make your algorithm as easy as possible or as low complex as possible. If you make your algorithm very complex, then you will have difficulties when you run it in an application. Okay, so this is the implementation. Yeah, you can get this plot. Then based on this plot, how can we interpret into some kind of operation? Let's say now, how can I deal with the calculation? Okay, if you say that, okay, I can run in the Python and I will check, and I will, after I check, then I will plot. Okay, yeah, that's the way to do with the running time. But with the theoretical analysis, so we need to have a basic understanding about primitive operations. What is primitive operations? It is a basic computation performed by an algorithm, and it is identifiable in pseudocode. It's largely independent from the programming language, and it is exact definition. But exact definition not important. So we will later see what is the reason, and assume to take a constant amount of time in the RAM model. So I do not want to discuss more about the RAM, but assume that the amount of consumption will be just constant. Some examples of the primitive operation are this one: evaluating an expression, assigning a value to a variable, indexing to an array, calling a method, returning a method. Okay. Now let's see. Yeah. Oh, I will use the pen. Okay. Let's see here. I have the. Oh, okay. I have this algorithm. So this algorithm, it is an algorithm in Python, but I don't want to say that it is a Python, but let's make it as a kind of pseudocode. Yeah. So the pseudocode, as I mentioned before, it is just a free kind of code to express the algorithm. And based on this algorithm, okay, let's try to figure out how many operations that you that you see here. Okay, so if you know how many algorithms, then you can analyze it later. Let's say now the basic operations. There are some examples like evaluating an expression, assigning a value to a variable, and so on. Okay, so let's see one by one. Find max. Okay, the first line. Okay, there are two operations. What are they? The line one, they have calling method. So the calling method will be one. Okay, if we call the find max, it will be one. And also assigning a value to a variable. We want to assign the value or something, okay, to the argument, to the variable data. So there will be two operations. Okay, and then what about the line three? The line three also have two operations. The first is about the assigning, the assignment. So if it is about the assignment, yeah, this is the first, and the other is indexing into an array. So this is two. So there will be two operations in one line. And next is about the line number 4. If we have the n, okay, so here we want to iterate the value from the first data until the end data. Okay, it means there will be n operation. Okay, there will be n operation repeating until n, but there are also two another operation. The first is assigning a value to a variable. So if I assign a value to the variable file, then yeah, it is one. And then the indexing into an array also is another process or operation. So because I want to assign the value like data index 1 equal to 1. Okay, so it means the array will be 1 and this equation will be 1. So there will be two operations. Okay, and after that one we have the line 5. The line 5 is two n operation. Okay, so the n here means it will follow the number of data. Okay, n it means iterated by n times. The same with this one, we have 2n because the line 5 it evaluates an expression. So this is the evaluation, okay, and it will repeat until n times, okay. So there are two operations and it will be repeated until n times. And the next one, the line number 6, it is 0 until n. What does it mean? So the worst case, okay, the worst case is to run all the values. But what is the best case? The best case will be 0. Okay, the best case is when the condition is not true. Okay, if the condition is not true, then we will not run this statement. But if the condition is always true, then it will always run. So the worst case will be n times, but the best case will be 0. Okay, because we are not sure about this if, then we can just make a kind of range from 0 to n. And line 7 will be one operation. So what is the total? Yeah, you can just total this one. 2 plus 2 plus 1, so it means 5, and plus 2n plus 2n plus n. Okay, so the total will be 4n plus 5. Okay, can you get the meaning? Okay, 2, so 2 plus 2 plus 1, so it will be 5. Okay, so the minimum will be 4n. Why? Because there's 2n plus the 2n plus 0. Because if it is the best one, 4n. But if it is the worst one, 2n plus 2n plus n, then will be 5n. So we can say that this operation will be minimum at 4n plus 5 and the maximum will be 5n plus 5. By using that one, we can say that it will execute 5n plus 5 for the primitive operation in the worst case and 4n plus 5 in the best case. And if we are dividing A is time taken by the fastest primitive operation and B is the time taken by the slowest primitive operation, we can make this kind of equation. Okay, so the time n will not be greater than the fastest or the A, which is the 4n plus 5, and the Tn will not be greater than the slowest one. So the slowest one, it means the P, which is the 5n plus 5. Okay. So if we can make this equation, then the running time Tn is bounded by the two linear functions. So this is the linear function that you can make. Okay. So how about the growth rate? Then the growth rate of the running time, it will be changing according to the hardware and the software. So it doesn't matter. Okay. So the Tn will be a constant factor, but it will not change the growth rate. So the linear growth rate of the running time Tn is an intrinsic properties of the algorithm FindMax. And yeah, we know that this Tn will be the properties after we know the 4n plus 5 and 5n plus 5. And oh, okay. I think why this is a matter, because when we are dealing with the time, yeah, you need to check this one. If runtime is c log n, then yeah, the algorithm is like just logarithm. Okay, there is no issue. But when it is like quadratic, okay, the first is using the c is the constant. Okay, but in the next state, if it is 2n, then you need to have 4 times higher. If it is 4n, then it is 16 higher. Wow. So if the growth is very high, okay, then this kind of growth rate, it will affect to the application, and especially if your memory of your computer is not that big, then it will crash your computer. Okay, so that's why this kind of analysis is necessary at the first time before you run your experiment in the computer, because your computer may have limitation, but this algorithm analysis will be very useful. Okay. So yeah, this one is the example. If you are doing the comparison, okay, the comparison of these two algorithms. Let's say I have algorithm A and I have algorithm B, insertion sort and merge sort. Okay, and let's assume I will explain this one later. So if you are using the insertion sort, you will roughly take 70 hours. If you are using merge sort, it will take about 40 seconds. Wow. Okay. So which algorithm do you want to choose? Of course, you will choose the shortest one, 40 seconds. You don't want to run the 70 hours. Insertion sort and merge sort are basically have the same purpose. They want to sorting. Okay. So if the goal is the same, then why we need to run until 70 hours? Just like make the 40 seconds. Of course, it will be beneficial for our time. That's why we say that the people would like to know about the constant. Okay, so the constants mean something is related with the growth rate. The growth rate is not affected by the constant factor and is not related with the lower order terms. So later we will learn if we have this number 10 power 2 multiplied by n plus 10 power of 5 is linear function, and this function with n power of 2, it is quadratic function. Okay, so we don't care about the number in front as the coefficient, but we just do care that it is linear, it is quadratic. So the constant factor can be just eliminated, or we can just dismiss that one. Okay, I will explain the big O notation, but maybe I will stop here so you can have more time to take a look on the basic things. Okay, I will continue again in next video, and hopefully you can follow this course. And if you have any questions, just feel free to send me email. Thank you.